Good morning, sir. I am Lavanya, Department of Electronics and Communication Engineering in Srinivasa Ramanujan Institute of Technology Autonomous. Subject Digital Circuits and Designs. Topic name Implementation of State Machines and Using Verilog Constructs. Introduction to State Machines. State machines are models of computation using to design digital systems. They consist of states, transitions, and actions based on input signals. Implementing state machines efficiently is crucial for reliable digital design. Project implementation all being here. Project implementation process. Planning, second analysis, third design, fourth implementation, fifth testing, sixth maintain. Types of state machines. There are two main types, mainly and melee and Moore machines. In melee machines, outputs depend on states and inputs. Moore machines produces outputs solely based on states. Inputs combinational circuit, output combinational logic to memory to combinational logic. Advantages of using Verilog. Verilog produces a hardware description language suitable for designing digital systems. It allows for clear and concise modeling of complex state behaviors. Using Verilog enables simulation, synthesis, and implementation on hardware. Area and timing consistency, synthesis, Verilog description, functional simulation, synthesis, placement and rotating timing simulation, technology library. Basic concepts of a Verilog state machines. States are typically represented using reg variable. State transitions are controlled through combinational logic. Outputs are assigned based on current states and inputs. Observe the extended state register counter. Sign initial counter if else block. If another condition, this is the program picture to observe. Modeling state with parameter. States are often defined using parameter for readability. Example, parameter id le is equal to 0, work is equal to 1, done is equal to 2. This approach simplifies understanding and modification of states, simulation and measured responses after initial state and model parameter essential. Observe the graph. Measured voltages, simulated voltages. Using reg and wire. Reg variables stores the current state and output signals. Wire signals are used for combinational logic outputs. Proper declaration ensures correct simulation and synthesis in Verilog program. Outer module is plain wire, rigged wire. inner module, wire region. State transition logic. The always block with at the date of sensitivity list modules transitions. Typically transitions occur on the class rising edge. Case statements are used to define behavior for each state. Draw the state transition table for the following state transition diagram. Observe the diagram. Outputs are outside, inside. Present state, next state, input 0, input 1, output for input 0, for input 1, 0 0, input 0 0 0, input 1 0 1, output 0 0. Present state 0 1, next state input 0 1 1, input 1 0 1, output 0 0. Present state 1 0, input 0 1 0, input 1 0 0, output 0 1. Present state 1 1, input 1 0, input 1 1, output 0 0. Example of a synchronous state machine. Use always at the date of Fawcett's clock to update current state. Included reset logic for initialization. Transition logic is embedded within the case statement. This is the circuit diagram to observe it. Implementation Murray machines. Outputs are assigned based on the current state. The output logic can be assigned based only the current state. The output logic can be included inside the state. The case block. Murray machines are easier to design due to their simplicity. Observe the inputs and outputs and arrow. Implementing Mealy machines. Outputs depends on both current states and inputs. Combinational logic is used to determine outputs. They can respond faster to input changes compared to Murray machines. Observe the combinational logic diagram. If A input 1, then T and QA, clock is entered to the combinational circuit. Then output is combinational circuit C2. Sample Verilog code structure. Declare state parameters and signals. Used an always at the date of Fawcett's clock or Fawcett's reset block for state updates. Use a separate combinational always block for output logic if needed. Reset and initialization. A asynchronous reset is common to initialize states. Reset logic sets the current state to a known starting point. Proper reset handling is essential for predictable behavior. Simulating the state machine. Test benches are used to verify functionality. Simulate inputs and observe outputs for correctness. Simulation helps identify timing and logic errors. Observe the diagram. Synthesis considerations ensure that the design is synthesizable for FPGA or ASIC. FPGA or ASIC is a simple zip logic gates. Use RIGs for state storage and avoid latches. Keep combinational logic simple to meet timing constraints. Common pitfalls. Avoid unintentional latches by covering all case scenarios. Be conscious with asynchronous resets to prevent glitches. Ensure proper synchronization of input to clock domain. Optimization techniques. Minimize the number of states to simplify the design. Use encoding schemes, binary one hot based on application needed. Keep state transition logic efficient for better performance. Meta heuristics optimization to evaluation algorithms, bio-inspired algorithm, physics-based algorithm, swarm-based algorithm, nature-inspired algorithms. Practical example. Traffic light controller. Model states for different light configurations. Define transitions based on timers or sensors. Implementation using Verilog with clear state and output logic. Observe the zip and logic diagram. Summary and best practices. Clearly define states with parameters for readability. Used synchronous logic with proper set signals. Text thoroughly with use synchronous logic with proper reset signals. Text thoroughly with simulation before hardware implementation. You observe this diagram. This is the digital circuits and designs logic Verilog program zip. In this presents in the logic gates to implementation to the multiplexers and optimization techniques, simulation and state machine to you observe the total logic diagrams and truth tables. Test thoroughly with simulation before hardware implementation. Conclusion. Verilog provides powerful constructs for implementing state machines Proper modeling ensures reliable and maintainable digital designs. Mastery of these techniques is essential for advanced digital system development. Thank you.